Okay, so my intention this week is to give you a brief video for the homework. As you can see, I wasn't able to paste in all of the things that I need to show you, so I want you to download this document, this Word doc, and I'll show it to you here. Okay, so the first thing I said I would do before the semester was over was give you examples for each of the tests we've done so far and a research question, and I'm asking you to do it exactly like this. So I'm giving you, from a school perspective, please place yours under each example, and it would be helpful if you change or highlight yours. So just come in here, click, 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 and then put yours in here, and then either highlight it or change the color would make it really easy for me to grade. Okay, so we have a one sample test, an independent samples t-test, paired samples, one-way ANOVA. I did give you an example of a two-way ANOVA because some of you might do that for your dissertation. All it is throwing in a second independent variable. Correlation, simple regression, chi-square goodness of fit, and a chi-square test of independence. And then for the homework, so that's the research questions, and then for the actual homework, I'm giving you this example, and I show you how to input it, and then this example for the test of independence, this problem rather for the test of independence, and I give you this as an example of how to put it in. So if I label it 1, 1, 2, 2, I'm going to label 1, text it while driving, and 2, no texting while driving, and then these are yes, no's. So I've clicked on variable view, and I'm in value labels and clicking back and forth so you can see how I coded those. These don't have any codes. I could have typed in for red eye, normal wing, number 1, sepia eye, normal wing is number 2. I didn't bother. This is just the frequency, 59, 15, 2, and 4. And then I'll show you in the video, I'll put the expected probabilities here so that I don't forget, but we don't actually use that column. All right, I'll show you how to do all that. So anyway, I just want to show you the document before we get started. I'm going to pull up SPSS. I'm going to pull up a PowerPoint with the problems. Okay, so this comes from number 3 on page 597 in the textbook. A developmental psychologist would like to determine whether infants display any color preferences. A stimulus consisting of 4 color patches, red, green, blue, and yellow, is projected onto the ceiling above a crib. Infants are placed in the crib one at a time, and the psychologist records how much time each infant spends looking at each of the 4 colors. The color that receives the most attention during a 100-second test period is identified as the preferred color for that infant. The preferred colors for a sample of 80 infants are shown in the following table. We have red, 25 kids looked at that the longest, green 18, blue 23, and yellow 14. Do the data indicate any significant preferences among the 4 colors? Test at a 0.05 level of significance, and then write a sentence demonstrating how the outcome of the hypothesis test would appear in a research report. Okay, so I have my data set here. I'm going to do 1, 2, 3, and 4. And in the red, we had 25. In the green, we had 18. In the in the blue, we had 23. And in the yellow, we had 14. Now I'm going to go to variable view. I'm going to value label those. 1 is equal to red. 2 is equal to green. 3 is equal to blue. And 4 is equal to yellow. Okay. Now, one thing I didn't show you, let me just pull up this. So we're just testing against the expected probability that each would be equal. They don't tell you that, but we're telling you, because they didn't give us any expected probabilities, we're just going to assume that it's 25% for each of the following conditions. So what I'm going to do is I'm going to go ahead, even though, let me do this. Color, oops. Oh gosh, I can't spell. Color and frequency. Okay. And I'm just going to do the expected value at 0.25, 0.25, 0.25, and 0.25. Okay, so now I've got everything inputted. I've got this column here, and I'm just putting the expected frequencies, even though they're equal. Sometimes they won't be equal. You might have 10 and 40 and 25 and 25, and you don't want to have to remember that or flip back to paper. So I just put it in the data set so I don't forget going forward. And so we're going to be doing a one sample t-test, but the first thing I need to do before I do anything else is weight my cases. So I come down here to weight cases, and I can't click anything over, so I have to tell it to weight cases by, and I want to do it by the frequency. And I say okay, and I weight cases by frequency. Okay, now I want to go to Analyze, Non-Parametric Tests, one sample. And it says automatically compare observed data to hypothesized. Well, that would be the thing that we would want to do for equal probabilities. But we're not going to do that. I'm going to show you. So we're going to click Fields, and you can see that this unnamed variable expected probabilities came over. All we want in this test field is the one categorical variable. So I say test field, and I'm going to say use custom field assignment. I'm going to come over here and do customize test. So I'm on settings. I'm going to compare observed probabilities to hypothesized, and I click options, and it says all categories have equal probability. Well, that's what I'm going to leave it as, because they're each one are exactly the same, but I'm going to show you how to do it when you have different probabilities. So I said for category 1, I'm expecting it to be 25. For category 2, I'm expecting it to be 25. And I wouldn't normally do this for equal probabilities, but I'm doing it here to show you how to do it when you have not equal probabilities. It works exactly the same. So then I say okay. Takes a second for it to think. All right, so what was my null hypothesis? My null hypothesis is that all of the colors were preferred by these infants with equal proportions. And even though we had, let's go back to the data, even though we had 25 and 18 and 23 and 14, those seem like different levels of expected probabilities. Even though we had that, we still found that there was no significant difference, because I come over here and it says retain the null hypothesis. And our significance value is 0.296. We had 80 kids. We had a test statistic of 3.7. We had 3 degrees of freedom, and our significance level is 0.29, which is not less than 0.05. Here's our observed, and here's our hypothesized. And you can see there's a big difference here and there's a big difference here, but it's not big enough of a difference to make it significant. Okay, so let's go back to the PowerPoint. All right, so in order to write it up, I need this information: 80, 3.7, degrees of freedom 3, and 2.96. So I go here and I say, there is no difference in the infant's preference for color, chi square, 3, n of 80 equals 3.7, p is equal to 0.296, or I could have just said 0.30, and then I went ahead and calculated Kramer's V. I just pulled up one thing, the SPSS keeps adding bells and whistles, but they don't add a Kramer's V for this particular test. So 3.7, and my sample size was 80. I just Googled Kramer's V or chi-square goodness of fit effect size calculator. I'm going to hit calculate, and I get 0.0129, so 0.01, which I have written here. And that's it. There's no difference in the infant's preference for color. Okay, so for the next problem, we're going to do a test of independence. So it says research results suggest that IQ scores for boys are more variable than IQ scores for girls. A typical study looking at 10-year-old children classifies participants by gender and by low, average, or high IQ. Following are hypothetical data representing the research results. Do the data indicate a significant difference between the frequency and distributions for males and females? And we're going to have to see, this is giving us a contingency table, and we have 160 on our sample, so we wouldn't want to go and input 160. So I'm going to show you how to do it the quick way. This is from page 600, number 15 in the book. Okay, so I'm going to go and just open a new data set. New data. I'm going to get it over here. Okay, so I have low, average, and high for my columns, and I have boys and girls for my rows. So I have two variables. The first variable is going to be 3 levels, low, average, and high for IQ. And my second variable is gender with 2 levels. Okay, then we'll come back and fill in the actual values. Okay, so the first thing I'm going to do is I'm going to go 1, 1, because I have to have, for low, I have to have a male and a female. Okay, then I come over here and I have medium, medium, and I have to have male and female. And then I come over and I have high and high, and I have male and female. So let's value label those real quick. So the first one's IQ, and the next one is gender. I'll go ahead, while I'm here, I'm going to just name this frequency so I don't have to deal with it later. Okay, so the first one, we have 1 is equal to low, 2 is equal to medium, and 3 is equal to high. And then I say, okay, I come down here, and I say 1 is equal to male, 2 is equal to female. And that's all I have to do for that. Now I have to get those frequency numbers. Okay, so we have 18, well, instead of saying medium, I should have said average, but we get the point. So for the boys, I have 18, 42, and 20. So this is the way I do it. 18, 42, and 20. So I'm going to go, oh, I'm in the wrong data set. Hang on, sorry. I'm going to skip 18, 42, and 20. And then I have 12, 54, and 14. 12, 54, and 14. Okay, so we're good. Now I have to weight my cases. Okay, so I want to weight cases by frequency. Say okay. I'm just gonna cancel this output and start over. So let me just weight cases one more time so you can see. Say okay. Here's my output. All right, so that's all we have. We have a clean sheet. Okay, now we're just going to do a crosstab. So we're going to descriptive statistics. Oops, we're going to come down to crosstabs. Everything's going to pop up on my other screen. So we remember that we had IQ was the column variable and gender was the row variable. Now it's got it as scale variables. I think that'll be all right, but typically we would want that to be nominal, but I don't think it matters for this. Okay, so I clicked exact, and I don't need anything there. I need statistics. I definitely want chi-square. I want phi and Kramer's phi, and that's all I want for that. I want my cells, I want my observed, and I want my expected, and I want row percentages. And that's it for that. Format, it doesn't give us anything, so we just say okay, and style and bootstrap, and I want to say display clustered bar charts. I'm going to say okay. Alright, so here we can see that we had 18 for low and we expected 15. Here we had 42 and we expected 48. 20 and 17, 12 and 15, 54. These are pretty close. And again, we don't have significance. So our chi-square was not significant with 2 degrees of freedom. All right, our Kramer's V is 0.15. Okay, and here we have our bar chart. And here in this one, they don't give you the expected and the actual, they just give you the bar chart between the two variables. Okay, so how would we write that up? So we'd say there is no difference in IQ level by gender, chi-square, 2 of n equals 160, 3.76, p is equal to 0.15, Kramer's V is equal to 0.15. Okay.